Okay, so in this segment, we're going to look at memory operations, that is, the operations which can be performed on memory. So, there are two basic operations, memory read and memory write. So, memory read is the act of reading from memory, and when I say memory, I mean your main memory slash primary memory slash RAM here. So, memory read is the act of reading a piece of data from the main memory. How it works, as we already saw a couple of classes ago, is you put the memory address into the MAR, a read command is issued, the data from that location is picked up and put into the MDR. The other operation which you can perform on your main memory is write or store. Again, the address where you want to write some data is put into the MAR, memory address register. The actual data which you want to write is put into the MDR, the memory data register. A write command is issued and the data gets returned. So these are the two operations which can be performed on your main memory. So we will now be looking at the next 2-3 topics we're going to be looking at are the core of instruction representation, which is your first chapter. So like we saw yesterday, there are different modes of writing your instructions. We looked at two modes yesterday, direct addressing and indirect addressing. We will be looking at a few more modes today. That is one way of classifying instructions based on the address of the operands, as in whether you directly give the address or it's a double pointer kind of thing, an indirect address, whether the address points to a location in the main memory or in the register. So depending on the address of the operand, when you classify instructions into different types, you call it addressing modes. But there is one more criterion for classifying instructions into different types, that is based on the operands themselves. So it is based on the number of operands and the nature of operands. So that is what you're going to see right now. So we'll a quick intro to that. Operands are the entities operated upon, the data, the values upon which you perform any operation are the operands. They have to be fetched from a memory location, which can be in the main memory or they can also be in the general purpose registers. So if you have an operand in the general purpose register, you can directly pick it up and operate on it. If it is in the memory, you should bring it from the memory to a register first and then operate on it. And how this bringing is done, we looked at in a previous class. Specifying the operands on which the instruction is to operate involves specifying the address of the operands, obviously. So if you want to add two numbers, your instruction will specify the address or the location where those two numbers are present, be it in registers or in the main memory. And then your buses will travel to that location, pick up that number, and the addition happens, so on and so forth. So within operands, you have types. We have source operand and destination operand. So source operand is the operand you take and you work on, and destination operand is the final location where you're going to put the value. So for example, if you take the statement C equals A plus B, then your A, B and C are your operands. They are the values which you are manipulating through this expression. So in this, A and B are your source operands, because those are the data, those are the entities you are picking up and working with. And C is your destination operand, because after performing your operation, which is addition, the final value is going to be stored in the location called C. So C is the destination operand. So what you are working with is a source operand, and where you put your resultant value is a destination operand. And when I use the word operand here, I am generally referring to the memory address of the operand. So when I say A and B are memory addresses. So in some cases, the same operand can serve as both the source and destination. So if you take this instruction, add A comma B, what it means is you take the value existing at A and the value existing at B, you add both and put it back into B. So this is the register transfer notation equivalent of your high level code B plus equal to A or B equals B plus A. So in such cases, A and B both are your source and B itself is the destination. So that is what this statement says. Sometimes you have separate source operands and a separate destination operand. Sometimes the source and destination may be the same. So depending upon how many operands you have, you can again classify your instructions into different types.